and Mastodon. I'm happy to listen to this talk, Tracking in Apps, an overview of the mobile tracking landscape. Malte, Benny, and Lawrence are active in the society Datenfragen, EW, and they will explain to us how mobile apps are still a black hole in terms of legality, what's actually happening, and what they think about these things. Enjoy. Welcome to our talk, Tracking Apps, Is This Legal? We want to give an overview over the mobile tracking landscape. This is Benny, Lorenz, and Malte. Benny was studying computer science and now is active in privacy and IT security, hates computers. Lorenz is studying physics and thinks that privacy requires a system transformation. I'm a PhD student at Technical University Braunschweig, like automatic analysis and all things privacy. You can reach us via email, also with PGP, and on Matrix, and on Mastodon. All three of us are of the Datenfragen Society, a society who would like to help you with privacy issues. So this is about tracking. Tracking for us means if an application tracks user behavior, and sends to the producer or others. So why is this happening? Mostly this helps third parties or the owners, but not the actual users here. So maybe you've seen in Firefox there is this about protection site. So if you switch this on, then you see how many trackers gets blocked by Firefox. For example, we have a screenshot here. So for me, about 270 trackers have been blocked in the past, which is quite a lot. And in reality, there's quite a lot because I had already installed some extensions that already blocked some tracking out of sight. So trackers are everywhere, and this might even be worse on mobile phones because apps on mobile phones have a lot more access to a lot more information than just the browser, like sensors, contacts. So, for example, the Deutsche Bahn app, the Deutsche Bahn Navigator app, of which there was a talk earlier this week. So they noticed that the DW Navigator app, where you can buy train tickets, sends lots and lots of data to Adobe, and well, that's not a good thing by itself. So yesterday there was a talk about that. So before we go into the details here and look what apps transfer, let's say what the developers of these apps say. And under iOS and Android in the app stores, developers have to declare which kind of data they collect. This looks something like that. Here, for example, in the Apple App Store. Here we have a screenshot of the Facebook app page. Two big categories here. So data for tracking of you as a person and data connected to you. And this is these are things declared by the developers themselves. So, for example, here on the left-hand side, it's tracking contact information, and in the link data, it's a lot more here. So three of us together with Simon looked into that, and we have published a paper on that. It's available via open access. So some parts of that. So there's another category called data not connected to you. But there are still things that indeed are connected to you. So, for example, like user ID or email address. How could it be that this is considered not connected to a person? So there's still some contradictions in that. And we noticed that 16% of all apps that we looked at transmitted data that have not even been declared in their data. So this means we cannot even trust this. So there is no no audits, no consistency checks in what data is there. So Google also introduced these labels this year. They are doing a bit more. They have slightly different names. In Google also, it's developers have to declare whether data are encrypted while in transport and whether you can delete data. So here's a screenshot of Google Play Store. And so we see these 4 points here. So app can publish, can give the following data to third parties, can collect this data, and so on. So we collected this in a systematic way and sorted by purpose. Because purpose number one is analysis. The basic functionality of the app is only on the second rank here. This means that the developers say that the main purpose of use of the data is analysis and not the basic functionality of the app. We found this a bit shocking here. So there are a couple of confessions here. For example, Facebook says they collect your political, including and also health data and sexual orientation. Same with Amazon here in this label, or this kids app, kids co-blocks, which is collecting sexual orientation for analysis purposes and store this here. So, which we also wanted to check whether this is correct, what's in the label. So we ran this app and monitored them. So we can only make statements about things that we observed.
So there's a lot of gray there already. We just started and then looked what happened. In dark blue, we have things that were declared incorrectly, and in orange we have the exciting part of the data that were not declared. And that's especially bad for the first category, which is location. And we want to have a closer look at what data is being transferred there. I brought you some examples that are a bit older, from 2020 and 2021. For example, we have Audible, this audiobook app. And they post, among other data, my screen settings. So, for example, it says portrait mode and my current volume and the name of my router, or the size of my screen. And the architecture of my mobile phone, the battery status and the charging status. And this is linked to IDs. For example, here we have an IT ID and a heading ID. And there's also a Google Ad ID that is assigned by Google, and it allows trackers to link information to one another. For example, here's the Adobe Ad ID, and then you have the visitor ID that is linked to it. So IDs can be linked. Another example, PayPal, where information is transferred to paypal.com, such as device data about our mobile phone, but also IP addresses and the name of your Wi-Fi, also your proxy and your location. That is horrifying. Or here, Bitmoji on Android. There we have timestamps when the application was opened, or that we've viewed the welcome screen, and every time there's a link that finds out whether you've installed certain add-ons. And here on the left side, we have all data, and on the right side, we have information sent by sensors. For example, the gyroscope sensor that sends and transfers exact data. And under iOS, a social media app called Paparazzi just sends off all your contacts from your address book. For example, we could.
Und jetzt haben wir mal ein paar so Beispiele gesehen, weil jetzt möchten wir uns mal gerne anschauen, wie wir das automatisieren können.
And I would like to look at how to automate this and make statements about the behavior of the trackers. So, as you might have seen in the other screenshots, we used an emulator, with an Android emulator with root. And you can instrumentalize it using ADB. ADB is the Android debug bridge, which allows you to install and deinstall Android. And when we install apps, we obtain all the permissions. And in order for us to be able to read the traffic, we use a machine in the middle called mit-m proxy. And in order to be able to read the data, we circumvent the certificate using objection and FRIDA. Because apps and websites can define which certificates they allow, and those apps and projection allows you to circumvent that. And FRIDA is a toolkit with a JavaScript runtime that allows you to circumvent certificates. It's a very powerful tool because it allows you to use dynamic methods, and you also have autocomplete for messages.
Und Objection implementiert dann intern.
Objection circumvents certificate pinning using FRIDA functions. So we can take functions out of the app and replace it by our own functions. We have a certificate checker here, and here we can see a certificate pinning process. And we just override that with our own function. So if the app wants to check the certificate, the overwritten certificate check is implemented, circumventing the check. But that means that we have to implement that for every check. And we might miss out on traffic if we don't do that. But it also means that everything we see actually happened. So now we can record HTTPS traffic using mit-m proxy, including the background noise, which of course we don't want because we want the traffic from the apps only. So this is what the background noise looks like. So this is just the clock widget that shows you the clock on your smartphone. And there you can see the connectivity check that your mobile phone does. For example, to be able to show you don't have internet access. Or for example, if you install apps on the Play Store,
Und was wir dagegen tun, ist den Emulator tagelang laufen lassen.
So what we do is we run the emulator for a few days without doing anything and recording. And at the end, we make a filter by hand that just filters out anything that happened in the background without activity. It's a bit tricky because many of the endpoints and APIs here are used for real apps. So we tended to throw out a little bit more than we actually needed, so that our results in the end are really accurate. And we can use this filter on other traffic in order to be able to extract the traffic that really stems from the app. So where do we get the apps from? First, let's have a look at which apps we looked at. We just took the top 100 free apps in the Google charts. Google has about 15 apps in each category. And we implemented something that allows us to view 66 apps per category. This library is open source and can be found on GitHub. And if we have a list of app names, then we need to download them. There's a lot of tools that do that, but some of them are a bit tricky and you have to try them out. We use the following tools: GC Play, CLI, Play Store Downloader. I like to use the 89Z Google Play, which has been renamed to an RNGH7R Google Play recently. But the tool works really well. But Gplay CLI and Play Store Downloader are a bit tricky. You have to try them out for a bit until they work when working with a lot of app. So now let's go to the iOS setup where my colleague Ben will go on. Yeah, with iOS it's a little bit more difficult. We can't use an emulator like we were able to on Android. There is an emulator, but it doesn't allow you to install apps. So it's useless, basically, for our purpose. So we need to use a physical iOS phone. But the tracking recording is easier. We can use the mid-M tool, like on Android, and these for certificate pinning circumvention we used SSL kill switch 2. It has the advantage that it's able to run in the background. In order for SSL kill switch 2 to work, we use checkrain as a jailbreak, but that's only available for iOS 14 as of right now. So we're a bit behind the latest apps. Also problematic is getting access to the apps. For Android, we had access to a lot of app charts on iOS. There's three ways to get to access to apps. There's a function that backs up apps, but this function is no longer available. But you can still use the feature.
So that leads you. That means you have to click on every subpage on every app to download it. And there are options, but it's not really reliable. You have to just hope that nothing goes wrong. There are configurable tools for older iTunes versions. It's for administrations. But so yeah, the configurator 2 also allows you to pre-install apps. The idea is not that it's being used for downloading apps, but the apps are saved to a download directory. Disadvantage is that it's only able to download already bought apps, and it's not about money here. Apple calls bought apps all the apps that you already acquired. You have to register them to your Apple ID at least once.
Kann ich aus dem Mac App Store ja jetzt auch iPhone und iPad Apps runterladen?
And because the Mac now uses the ARM processor and you can now load apps to that as well, but it's quite limited. And the developers can decide if the app should be able to be downloaded to the ARM Mac, but yeah, so it's quite limited. So there are unofficial tools, of course. The first one would be the Amazing tool. It can download apps and then provides a file, but again, only bought apps. And that's because Amazing uses the APIs provided by Apple. So they have the same issues. Then there is 3U tools. And it's a tool for everything you might want to do with an iPhone. And it also has the option to download apps. And it's quite promising, because this can also download apps the Apple ID has never seen before. So not only apps marked as bought. And again, you get an APA file and can then install it to another iPhone. Unfortunately, there is still an issue because the apps I can download is somewhat limited. And for some reason, I could not find the COVID warning app, even though it should be available. But because this was closest to what we need, we had a closer look. For iPhones and Android, we already installed the proxy for capturing the traffic, and interestingly, it works onto Windows. And the first thing I noticed was that there is 2 requests to buy.iTunes. So it's not using its own service for downloading apps, but it's using the Apple endpoints. So everything is working on my device. So if we check the request, the tool is naming itself as an older version of iTunes. And that's why, in contrast to Amazing, it can also download different apps, new apps. But it also tells us that there is no technical reason why it shouldn't download all the apps. And the reason why it's limited is that, and we do not know why, it has its own endpoint for listing the apps, and that is limited. So yeah, now we found the problem and can solve it. Because our proxy cannot only read requests, but also write them. So now I can catch all the requests to this endpoint and overwrite it with those apps that I take out of the lists. So now I just give back my list instead of the official list. And now suddenly the tool can download all the apps that I want to download, and it actually works. So even apps that I couldn't download before, I can now download. So there was no good reason for this limit, and I really do not know why it's there. So now we have a functioning way of getting the apps. So if we want to download 1,000 apps, we have to click 1,000 times to the button on the button. And in the first try we did that, and it works, but it's not fun. And the problem is, if you put too many apps in the queue at the same time, it gets stuck sometimes. So you always have to kind of monitor it.
Zum Glück hat sich, seit wir dieses Projekt gemacht haben, auch
Luckily, since we started this project, some more work was done, and now we have the IPA tool, and it's the first command line tool for loading apps. And of course, it's much easier to automate this.
das Problem bei IPA.
The problem with IPA tool is, well, was
dass es eben auch nur Apps herunterladen konnte.
that it can only download apps that the ID already knows, that's already connected to the ID.
Müssen wir aber zum Glück nicht wirklich.
So that could have meant that we have to stop, but it doesn't, because IPA tool is also open source. So we can check the code and adjust it, and that is a great advantage. I tried to write my own tool before, to write my own requests, but it never worked, and I just stopped at some point. But with IPA tool, I suddenly had a working tool, and I could just adjust the source code. So I spent some time with it and fought with Apple service with a goal to add the support for getting new apps, buying new apps. So as mentioned before, there are different endpoints for iTunes and the configurator too, and this new tool uses the endpoint for configurator 2. And I could change it, I thought, but that didn't work. Because when you log in with Apple, you need some parameters, not just your username and password and tokens.
Das größte Problem
To generate a token, you need more parameters.
eine Art von kryptografischer Signatur oder so.
There is some kind of cryptographic signature,
Und an der Stelle leider auch erfolgreich ist. Wenn man dann
and that successfully keeps me from logging in automatically. There are forums in Chinese and Russian, and people said they were successful to reverse engineer this, but they never tell you how. So that didn't work.
und dann habe ich eben mit Configurator
So I then,
und mit dem
oh yeah, right.
man sich über Configurator 2
If you log in using configurator 2,
nötig ist, um sein Produkt zu kaufen, nicht aufrufen, sondern kriegt die
you
Nachricht.
cannot access the point where you buy a new app, but you always get the message that the login expired, and you should re-log in with the hint you should use iTunes. But that's not possible, unfortunately. So yeah, I fought a lot with Apple and tried a lot of combinations between endpoints and header configurations. And in the end, I succeeded to open the byproduct endpoint with my configurator ID. And I added this to the IPA tool, and it was merged. So now, with the IPA tool, you can add new apps that you had never bought before. And this is obviously great. Originally, the tool was written by in Swift, but now it was ported to Go. And now it should run on any system, which is great. Okay, great, now we can download apps. Now we have to install them somehow. And here configurator 2 is really helping, because there is a command line utility that can install and uninstall apps. Configurator 2 only runs in iOS or macOS, but there are also tools for Linux, and these can also install and uninstall. What we need now are some small things. We could have used ADB, which is not available for iPhone, obviously, but there are others.
So we have to do interpretation, like if event XY happens, then we want to trigger program Z. And luckily there is a terminal program which you can use for that. And with another jailbreak trick, we can install this on our own on a server here, log in on our computer, and run code from there. So, for example, I can automatically push the home button or use apps automatically in there. So there's a hint. There is this command activator listener and gives you a list of all actions, and there's a huge amount of things you can try there, and this would have helped me a lot if I had done this a lot easier. Okay, so Vector Listeners gives you the whole list of all the commands you can run. This is very, very helpful. Still no documentation, unfortunately, what they do, but at least you can guess from the action's name what they do. So what we now need is a possibility to give apps the permissions to that, because we require all apps to have all the permissions. So we see the worst case behavior of the apps if they have the right all permissions. There was no prior art for that, unfortunately. So no one has done this or not documented this. And of course, Apple doesn't support that by itself. So we had to do this ourselves. And so my thought was there should be some kind of permission system in Apple OS, in Mac OS. And a lot of things are similar between Mac OS and iOS. So I was hoping I could see some parallels there. And on a Mac OS, the framework in Mac OS is called TCC. And it has a small utility called TCC util for the command line, for which that's possible. And so I logged in and run this. I tried to run this, and it's not there, unfortunately, on iOS. On the Mac OS, there's a daemon for that, a TCC daemon. And I was checking whether this is running under iOS. Unfortunately, not as well. But I still didn't want to give up. So it's well known that where these databases are located under macOS and how it's named. So let's try to find that one and see. There is a file like that on my iPhone. So let's have a look into that database. So that's how it looks like. Here, the screenshot is from an iPhone with just very few numbers of apps installed. So there you don't see many rows here in that one. But on an iPhone, that's used a lot more, significantly more. You see lots and lots more lines here. Still, there are a lot of interesting columns here, like this client one, the service one about which services are being used. So it looks like here for the corresponding permissions. And there's an auth value, what the telling us whether the permission was rejected or confirmed here. So we can check what happens when I change the corresponding column here, and we see that if I change anything in this column of the database, the corresponding permissions app also has this change. So we see this way we can automatically give permissions to all apps here. Problem is that we do not have a list of IDs of possible permissions. And it's even worse, we don't even have a list of all possible permissions on iOS, because in this app, the app only shows permissions that app are actively requesting. So if we want to get a list of all apps, so we still we need to find out which permissions may exist at all, which would take quite a lot of efforts, and it's very likely that we might miss some. Luckily, it is not necessary, because in the file system I found a localization file that contains translations for this framework. And if you look at that, then you see that the keys as a suffix have the name of the permission, and the string is then the translation if an app asks for the corresponding permission. So I know what keys, for example, KTCC service reminders is, because it's for the reminders, obviously, and this service user tracking is a permission which might exist, but which I might want to refuse to an app. So from this file, I can create a table with all possible keys. I did this, and this is the first page here, and there's a second page. And on the second page, we see an effect which sounds a bit weird, like authorization test service prototype, put 3 right. So if you refuse this one or give this one, nothing changed in the permissions. So this probably is something from internal testing by Apple, which are not included in the final system, but for whatever reasons, Apple has forgotten to remove this from the system file. So this means we now have the possibility to give all possible permissions to an app like a flashlight app here. All permissions. Unfortunately, one permission is missing, which is the getting the actual location, GPS location. Although this would be extremely important for us to know on whether an app requests your local position. Unfortunately, this permission is not managed by the TCC framework, and at that time, I didn't find out whether anyone had found out how this works. So what we've learned already is that Apple is storing some interesting stuff in SQLite databases. So I try to look around for files like that. So I wrote a small script trying to find all SQLite databases in the system. Then goes through all tables of that in corresponding tables. Tables in the corresponding database, and then does some kind of grab and trying to find the idea of a certain app. And this app, earlier I have given the permissions to receive the location data via the permissions app. So I would see the changes in here. So this one returned a couple of results. So not surprisingly, the one I found before. Unfortunately, all these were false positives here. We didn't really find how this where this works. So a hint here: if you want to look into details, internals for Apple OS, it's very helpful to look into the forums from JPEG community, because they are looking into these kind of things. There is some open source information available out there. So this, for example, is a JPEG app called Force Reset, which can not set the permissions for location, but at least it can read out the permissions, and I can read the code where this is. And I learned that there is a CL location manager class, and it seems to have something to do with what I want. So yeah. So here, location manager key sounds like what I'm looking for. So this might be very helpful. Unfortunately, all these interesting APIs for that are something that's Apple internal. So there's no documentation, and it's tricky to get to that point. But Malte already gave you an introduction to Frida, which is a super helpful tool, and that one has this very helpful function. So I injected myself into the flashlight app via Frida, and looked what was being called here, and I for this nice function, set authorization status by type for bundle identifier, which will sound exactly what I need here. So I tried this out, whether I can give location permissions to my app, and well, unfortunately not. I tried this out. Frida crashed, my app crashed, and when I rebooted my my mobile phone, the permission was not there. Luckily, I found some other tools there, which so a debugging tool that gives you a list of all functions that an app uses, all APIs that an app uses. And I know that while starting the permissions app, getting a very long list of API calls internally, too long for me to read through, and then in the set permissions app, I set the permissions for that one, and then I look at the list again. And this line here is exactly the function that we called earlier before. So why does the permission app why it is able to set the permission, and why can I do that? And enlightenment don't. I need to do this not in the context of the app that is requesting the permissions, but in the context of a higher level app, because obviously an app shouldn't be able to request its own permissions here. So I need to do this in the correct context here, and then it works if I do this with Frida.
And what is left is this value parameter that can be set or not set. This wasn't documented, but it's just an integer. And those are the possible values that I could have used. And in the same way, I can also find out whether an app has a location permission or not. And that applies to any apps running or not. And that enabled us to determine all of the required permissions from the Flashlight apps. In the same way, we can also copy information and later paste it. And this is interesting, of course. So we not only managed to master Android, but also iOS, and then put out statistics about thousands of apps. Our idea was that we don't get into contact with the apps. We just run them for 1 or 2 minutes and look at the trackers. In my master thesis, I looked at almost 4,000 apps. And the results are very promising. 78% of the apps I looked at contacted at least one tracker without any interaction on the app. Those are the trackers that the apps contacted. The 25 most contacted trackers. I compared the DNS results from my test station with a library. The prime suspects are Google and Facebook. But Google isn't only on first place on Android, but sadly also on iOS. So having an iPhone doesn't get you out of being tracked by Google. So those are only the 25 most used trackers. There's a lot of others, of course. When I look at the location those trackers work from, that's mainly the US, which is problematic in light of the EU regulations that were recently introduced on that. 33.3% of all requests without interactions went to tracking service. So, of course, we were interested in what data is being exchanged here. We recorded the network traffic, but we needed a way to automatically extract information. So one possibility was to look for values we're already familiar with, that we placed on the apps on purpose to see whether any apps would use that. That actually works. In this way, we can recognize those values not only in plain text, but also base 4 encoded. But this approach comes with two problems. One, it only works with static, previously known data. So, of course, some data will change in the course of the app usage. And spoiler, of course, they're transmitted, and we would like to know about them. And also, the name needs to be unique. So we use arbitrary strings so that we can be sure that we're dealing with our own data and not arbitrary hits. Just because if is somewhere in the traffic, we can't conclude that certain information was transmitted. The second problem is that tracking data requests are absurdly complicated or obfuscated. What do I mean? This is a supersonic request for an ad, and you see that there's a few parameters in the URL already. For example, which app it's about. And then we see this big string, which we basically can't derive any useful information from. Let's look at what's in there. We could have circumvented this automatically, but it stops here. If we decode that, we get a binary block that we can't use. So this is a gzip archive, so we need to unzip it. And it gives us a JSON that looks more like what we're looking for, but it's not really machine readable yet. So we need to process it somehow. We go into the data string, and if we look closely, it's not a string, it's actually a JSON that was transmitted as a string. So we need to parse it, and now we have the machine readable data. And here we see that this request actually contains a lot of data and looks like the requests that Malte showed earlier. And this wouldn't have been possible with a generic plain text approach. Next example, a Facebook request. Here we see that this is a JSON object, but also not machine readable. If we focus on the batch property, we see a string with a JSON object again. So let's JSON parse it, and that gives us an array of objects that have a relative URL each. Let's take them out, which gives us a list of URLs. Then we do get parameter. So we run a query string decoder, and this slowly takes us to some data which we can actually use and analyze. We get this kind of structure, and you see this custom events property where it's, again, very complicated, but I think it's clear that trackers are really creative in using formats to obfuscate their activity. And I don't see a possibility. Just Facebook has so many request formats that work in so many different ways. So I don't see any possibility to write generic code that is successful in decoding all of those different formats. So we need a different approach, and the good thing is that there is one. As we saw before, the tracking companies, there are many tracking companies, but there's a few companies at the very top that do a lot of the tracking, and we can make use of that.
So this is similar, but more finely reduced. So those are all the endpoints and sorted by how often they were accessed. So we have a few points that were accessed a lot of times, but it gets the numbers get smaller quite quickly. So the expectation would be that if we want to write a handler, those know how to extract the data for a specific endpoint. We have a good chance to maybe not decode everything, but a big chunk of everything. And that's what I did. I wrote 26 adapters or handlers for this, and those were specific for one endpoint each. And so they are able to extract the data of one endpoint. So it was a little work to really understand the data format and then write a script that can automatically extract the data. But with just 26 adapters, I could read 10% of all traffic. So just 26 adapters are 10% of traffic. And not just the tracking traffic, but all traffic. So all the apps, including the normal app functionality. So this is actually a viable approach. So now I can check what the apps are submitting, what kind of data. So those where I had an adapter, I was using it. And for all other data, I was using a string matching as a fallback. And here, the data that was submitted. And of course, there is quite boring data that I can understand. Apps might want to know the app ID, the OS version, the app version. That's not critical data. We're not worried about that. But the problem is somewhere else. So I also checked, is data anonymized or is a pseudonym used? So was a unique ID used and sent with the data? So if there's a pseudonym, then there's not just the information someone used this ID and has used this OS version, but it is a specific device. And Lawrence will go into more detail because this is important for the law as well. And in orange, we see there's a pseudonym. So most of the data is with a pseudonym, which is more critical. And all of this was without interaction. So that also limits the kind of data that can be sent. So user input cannot be sent because there was no user input. Still, we already see, even without interaction, that a lot of critical data, for example, location data, is being sent. And very often not even anonymized, but with a pseudonym, with an ID. So, we already told you how widespread tracking is and how almost impossible it is to evade that. But we don't want to scare you. And we don't want to leave you alone with this, because tracking is everywhere. But we want to give you options to defend yourself. So we wanna present two ways to defend yourself. One you might know, and one maybe a few of you use. And those are technical actions you can take. So first, let's check who are we dealing with. And every one of you can do that using Exodus. It's a database including a lot of apps, and Exodus analyzed them. And they were just checking in the code for the app. Are there code signatures of known trackers? Google Analytics, for example. So whenever you enter the name of the app, you can check, does the app use those trackers? And then the tracker might be active. They don't know, they can't know for sure if it's tracking you, but it might happen. But that also can help you decide what apps do you want to use. Also, Exodus can tell you what URLs the apps are connecting to. And then you can use that to just block those URLs. For example, using a Pi-hole, that's a small DNS server that can run locally on a Raspberry Pi or something similar. And this now redirects DNS requests to known tracking addresses into a black hole, basically, and blocks them. So trackers are made unfunctional. And that's a very simple and effective way, because it's not just protecting you, but also everyone using a network who used this DNS server. So you're not just protecting yourself, but also your family, your office, your friends. And of course, there are other really cool ways of protecting against tracking, and we really recommend to look around, because we are not experts on this. There are further options. So the cookies block, for example, has a lot of good recommendations, and just use Google a bit. But yeah, definitely something of you. It's not something everyone can do. It's not something my grandma could do to protect themselves. And that's not a good state of things. It's a social problem. And the business models behind tracking, they are the problem, and they should be attacked. So we think we need a social solution for this. And we found one way we think we could use, just judicial force. Because we know not everyone can just protect themselves technically. It can be expensive, it's work, you need to know a few things. So what does it mean to attack it judicially? Well, we are lucky in the EU. There's the GDPR, and that sets high limits to working with data. But is tracking affected by the GDPR? Well, the GDPR is about working with personal data. So what does that even mean? What does this legalese mean? So personal data is all information that's used or can be used to identify a person, a natural person. So email addresses, for example, or some other ID, your mail address maybe, but also just an ID number. And we see that a lot. So tracking, companies always say, yeah, no names are included, so it's not personal information, but the GDPR says, no, an ID number can also be personal information. But what does it now mean to work with this data? And working with can mean a lot of things. But yeah, the GDPR also includes the reading out and transmitting of this data. And of course, tracking does this. It's your personal data. It's about reading that data and transmitting it to the tracking company. So yeah, so the GDPR is applicable to the tracking case. But does it affect the companies at all? Because GDPR works in the EU, it's law here. But many tracking companies are not within the EU. Many of them are in the USA, or in China, or other countries. So we have to ask ourselves, does it also work, or is it applicable outside the EU? And yeah, GDPR says yes, it is applicable as long as they have access or want access to the EU market. And this is because they are dealing with you as an EU citizen, or they are observing you as an EU citizen, and trackers obviously do that. So if they are tracking you, and no matter if they are within or outside the EU, GDPR applies. So as long as you are in the EU, GDPR applies. So is it even legal then?
So it's obviously that the GDPR is applicable here, and then we have to look at the GDPR, and it says that every processing of data requires a legal foundation, and there are a couple of cases when processing of data is legal. First one is you explicitly opted in, but it's also if it's required to fulfill a contract, like buying something here, or for example, if a company is legally required, for example, for tax reasons, and data needs to be stored because of that. Retained because of that, or to fulfill your vital interests, and this also allows a company to process your personal data. Also, for in terms of public authority, like police or public officers, public authorities. And the famous one is the if people so in general people so there's the case of justified interest, which companies often claimed, but this is also really required if this does not collide with your interests and freedoms. So in our case, we can already strike out quite a lot of legal basis for tracking, because it's obviously not legally required. This is not a vital interest here. It's not to keep you not necessary to keep you alive, obviously, and obviously also they do not have public authority here. I mean, you know, there's this state Trojan, but but here actually there are three possible legal foundations for that, and there's a lot of negotiation part here, and and in general all privacy authorities have said that the only legal base for tracking to be legal is opt-in. And also the privacy conference, the couple of other data protection organizations. So these all data privacy protect agencies, societies say that this is really the requirement. And similar here with the e-privacy guidelines, it says the e-privacy regulation looking more into privacy of end devices, and it says very clearly that if any application wants to get access to data stored on your device, like tracking pixels, things like that, that this is only legal if you actively opted into that. And so we are on the safe side here in that. So this is only a guideline, not a law, not a regulation. And so in legalese, this means that it is not automatically valid in all of the EU, but each individual EU country has to create their own law based on this guideline here. So this is still work in progress. The legal base for that in several countries, couple of court cases here. So this means that meaning you cannot we always have to look at local laws, at state level laws, if you instead of referring to the e-privacy guideline in terms of legal case. So only consent, opt-in, only consents. What does it mean here? So what does it mean in World Wide Web? So for example, if you look at the cookie banners, where you have to so do you consent to that? And quite often they are pointing to these things, point to this e-privacy guidelines or GDPR, and they claim that it's their fault that you have all these banners. But we have to say this is not the case. This is wrong. First of all, the GDPR is not the GDPR doesn't require you to force you to process data. You could just stop processing data. And also, if they were following these legal cases, they should be a lot easier to use. So on Benny's website, we have a collection of possible cookie banners, and we had that, but we don't have time to look into that in detail. So instead, we will have a look at some examples. What is actual correct consensus, actual opt-in here? So it needs to be a unique, unambiguous act. Not like the examples here. If you continue, you agree. So it doesn't. So you don't see any button that says start tracking. So this is obviously not a consensus. Same with rejection. If there is no button for rejection, no rejection to reject this, or if it's hidden behind several layers, then this is not legal as well. So to refuse to have your data protected must not be more difficult than to accept. Also, buttons need to be unambiguous. There doesn't need to be something like a label like "OK" is not legal. That's it. Or manage my choice. That's not legal. This is not a clear and legal labeling of these buttons. And also, I am not allowed to highlight buttons in different colors, whether with color or whether with size or anything like that, or skip links on the top right here. So these patterns are not legal. It's not allowed to use those. I also am not allowed to make them a precondition for even using that sense. So I'm not allowed to just close the app if people refuse to accept. So it needs to be a free decision for people to use that. So if an app violates even one of these criteria, then this is not a legal so an opt-in in the legal sense, a consensus in the legal sense. So this means that tracking is happening without a legal foundation, and thus it's illegal. So, so you already getting the feeling here that you have clicked through lots of these consensus dialogues, and so we had a look at those, and we looked into them in a closer way, and wanted to check automatically on whether they fulfill this. There are a couple of different approaches.
For example, the transparency and consent framework that was created by several EU organizations so that they can be shared. So basically, it's an API, a programming interface, where consent management platforms, so the consent dialogues, can interact with the tracking scripts and can tell them, okay, there's a consent or there's no consent. That works via a JavaScript function, which you can see here, the CCF TPI, and that gives you an object with all of the functions. For example, which consent management system was used. This is OneTrust in that case. And it shows whether a dialogue is actively being shown or not. It shows in which country the publisher is based. And you have those objects that take whether the consent has been given or not, and if the status has changed, this is reflected here. So this makes it very easy to check for consent. And on the apps, that isn't that common. There's a TCF standard also for apps, but our analysis have shown that they're not used that often. Also, it turned out that the standard consent form is not sufficient and does not comply with the GDPR. But we can see that in Android apps, this kind of consent is not implemented. Only roughly 21% showed any kind of consent, any option to give consent, and only 2.55% used TCF settings. So how about other platforms? Do they use their own consent management platforms? But there's hardly any. So yeah, that's quite rare, and that instead dialogues are parsed directly. And we did a text recognition on that. And used regex for a typical consent text. And also we used heuristical analysis for additional mechanisms in order to avoid false positives. Then we differentiated between the consent elements. Only a dialogue is actually able to obtain consent. Those kind of passive dialogues, for example, that tell you this website uses tracking, does not allow you to actively consent. And we found that most apps don't ask for any consent. They have no information on tracking, and another 10% only give you a notice where you can't give consent. So 90% of apps don't even ask, and only about 10% have dialogues. And we looked at those, and we saw that the dark patterns that we showed earlier are used by 90%, more than 90% of consent dialogues. So which dark patterns did we find exactly? We have a nice graph here. On the left, you can see the violations that we registered. For example, there's an accept button, but there's no reject button, or the buttons are incorrectly defined, so there's not accept and reject, but other wordings. That was in almost 40% of cases. Then only highlighting accept in color is something we often found, and also that the app stops after reject. So then we looked at which violations occurred in combination, and the very worst combination for users is this, like there's no reject button and the accept button is badly formulated, and we see that in 30% of cases, 22.7% of cases, and the second worst is no reject button. And here with 14%, we have a colored accept button and an unclear labeling of the reject button. So you can see your feelings are not incorrect. Most apps want to swindle you out of consent, of your right to consent. And you have a right to complain. You can file a complaint to regulating authorities if you're sure that there's a violation of the consent laws. You can contact the regulating authority for free, and they are required to take action and look into your case and check whether this is the case, make their own analysis, maybe even look at the service of the tracking companies, and then they can dish out fines that are pretty hefty. It can be about 5% of the company's annual turnover, so that actually hurts the companies, and it's a very powerful legal tool. But you have to admit that it's not really being used and implemented. The regulating authorities are completely overworked, because as we've seen, basically all of the tracking that is going on is illegal, and those authorities don't get active on their own. We have to basically force them to take action. But that takes a lot of work and a lot of patience, because for a long time, for years, you can't really do anything. The process just draws itself out. We did a test in a workshop. If you want, you can look at the slides, and we also published a complaint that one of our members filed against Otto, tracking in the Otto app, which is a popular shopping app in Germany. So it lists the violations found, the analysis used, the legal case, and the tracking behavior of the Otto app. So if you're interested, have a look at that. But it takes a lot of work. It's a very drawn out and long process, and you can't expect like regular citizens to do that constantly. This is what we have to change, and this is why we need to automate the complaint process and break it down to a few clicks.
So this is why we want to really document well the code that we already talked about and make it available as tools and libraries. So at least the analysis part of the apps isn't as difficult anymore. So you just start a tool and you start it, and outcomes prove that your rights have been abused. So if you want to join us and also want to work against tracking, stay in contact with us or start contact with us. We are quite active on Mastodon, and whenever anything changes, we'll talk to you and talk about it. We'll give notice when we publish our new project, and of course there are blogs and analyses. So yeah, check it out, talk to us, and if you're really motivated, join us. Other than that, that's it. Thanks for listening. We're looking forward to your questions, and the slides are online on our website. Yeah, thank you very much, Benny Malte-Lorenz, for this interesting talk. Let's get to the questions. Again, you can ask your questions using the hashtag Feierchance on Mastodon and Twitter, irc@hackint.org with Feierchance 2022, or 22, and on Twitch. There were questions about the consent dialogues. How can one analyze the consent dialogues?
So you have to really differentiate between the web dialogues and the in-app systems. In web, Lawrence had told there is this framework here which returns a lot of data in a machine readable way, which you can automatically look. And usually websites are using certain content management platforms, which are quite standardized by now, and we can check specific data here. So the different organization had did a mass large process against those, and they looked in particular into one platform, OneTrust, wrote a couple of specific scripts for that, so that they can analyze that. Problem is, so in mobile, this is a lot more difficult. So first of all, the standard is this TCF standard is a lot less standardized, and we also found a lot less standardized process. So my approach was much more primitive. So we only looked what is the text in this typically in one of these some of these dialogues, and how can I recognize then which elements exist. So we did this with Applum, with a framework usually used for automatic testing of apps, and we similar. So you can give it a DOM-like structure of the app, and this allows you to do automatic analysis. But this is not by far not as good as not correct as DOM here. So for example, it's quite often it happens in games that in games text is not as a text in app, but rendered as an image already, and there are lots of attributes that are not shown like that. So for example, I cannot recognize links. I cannot recognize what URLs, what servers these URLs go to. So you can use quite a couple of heuristics, but so we do not have a ready to use solution for that. It's all of this work in project. And next steps we are going to do on our side is trying to create a couple of libraries for you to use here.
And again, about the essential cookies, our necessary cookies. What can I think about that?
Yes, what's technically required? So there are two dimensions here, which there's a legal dimension and there's a technical one. So technically required, it always confuses me if websites ask for that, because it's not even required to consent to that legally. So if it is technically required, you can only guess what the apps do with that.
Das Spannende bei Dialogen ist ja auch, wenn man das bisschen kurz macht, die Security.
The interesting thing with dialogues is from security here. So if I click on accept in this dialog, I directly run code on this website, on the website that it can execute. So this is not only interesting from a privacy perspective, but also from a computer security perspective.
Maybe more of a social, political question. What technical solutions of individualized data protection exist, and what problems result from that? Because they are just individualized.
Yes, so I introduced a few of these solutions, and what's very used a lot is a DNS blocker that interject into the network traffic and interrupt the data flow between the your computers and the tracking servers. There are a couple of solutions for Android, but in the Android example, you see that you need root access to your mobile phone, so that's even possible to install these specific apps here, and so it's a really high technical, a real high effort thing on a technical level. So a Pi-hole is easy to set up, like 2 hours if you have the hardware there. But I mean, the whole thing is it's a fundamental right. It's in the Human Rights Charter in the EU, and it's really annoying. It's a really bad thing that the only way to fight against this seem to be some technical solutions, some complicated programs, and doing lots of effort to get technical protection, because even in that case, it would only protect yourself or people living at your home or office. Many people don't have the technical capabilities or the time for that, or the money, or couldn't afford these technical solutions, and so there are a couple of marginalization categories, meaning that some people are affected more than others from that, and so I would say this might be done on purpose in capitalism, because in any other places like food politics, getting good things, getting safe things is more expensive than the common cheap stuff, and so having individualized data protection, individualized privacy is a privilege, being able to do that. And so what we really want to use the actual legal judicial ways on taking action against these things. Maybe even take the streets, maybe even organize protests against that.
One interesting question. The creators of apps, concerning them. So the GDPR has quite high limits. Does that influence how the creators are changing? Are they adjusting the tracking behavior of the apps at all?
So we ourselves we didn't collect any data before GDPR. So but the folks at NEUB had a look at that once in 2021 and once this April this year, and compared the dialogues there, and they noticed that there really are some improvements there. Less violations against these dialogues and less other violations. So if this ports to apps as well, then we expect some improvements. Well, so there are improvements, but on this, the effect we see on this damage claims here, based on the GDPR, on the legal level, but also on a FOD level here, that it can actually sue developers here, these companies here, and so this word got around that violating GDPR can give you a lot of legal damage. So developers start improving.
So what about those people who only offer access via their apps?
I know that at certain websites having some pure models. So where the only options either having tracking and use it without fee, or pay for having no tracking. The whole legal situation for that is unclear. So I think they are 100% sure they say what to think of that. At some place I've seen people argue, or websites argue, that free will isn't affected by that, because there's no monopoly there. People can always go to a different website, but the authorities seem to disagree, at least with that.
Okay, as far as I can tell, that's it with the questions. You answered quite extensively. Thanks a lot again to Benny, Lorenz and Malte, and all those who helped with the talk behind the scenes.